Alright, so today we're going to be doing 611, which is going to be solving radical equations. So when you solve a radical equation, you want to make sure you isolate the most complicated radical to one side of the equation, raise each side to the power equal to the radical's index. So if it's a regular square root, you're going to raise to the power of 2. If it's a cube root, you're going to raise both sides to the power of 3, fourth root to the fourth, and so on. Your solving will result in a polynomial that you can solve either by isolating the x and solving like a linear equation, or by factoring if it's quadratic, for example. And then the most important step is checking for extraneous solutions. It's really common that you get to a point where you're solving and you think you have the answer, but it actually doesn't check out at the end. So we're going to talk about how to check that. And on the homework, it's really important that you do so.
I'm so sorry, do you have a eraser?
Yeah, I do. Hang on. You're welcome. All right. So let's go ahead and do number 1. So the first thing you want to do, if there's only one root, there's only one square root or cube root or whatever it is, you want to isolate it. So what are we going to do with that 5?
Subtract it and move it to the other side.
Yes, we're going to subtract it and move it to the other side. Once my tablet turns on, I'll do that. Just give me a second. There we go. Okay, so I'm going to subtract the 5 on both sides. That's going to give me the the regular square root of 3x plus 4 is equal to 5. And then we're going to put each to the power of 2 to get rid of the square root. This cancels out and leaves me with 3x plus 4 is equal to 25. And now you can just solve it like any other linear equation. And you get x equals 7, right? Now, we don't know if 7 is a real solution or if it's only extraneous. So we have to verify it before we identify it. So to do that, we are going to take the original equation and rewrite it, but instead of x, you're going to put in whatever you just solved for x to be, which is 7 in this case. And then you're going to go ahead and solve each side if necessary, and then see if each side equals each other. So what is 3 times 7? 21 plus 4?
25.
What's the square root of 25?
5.
So this is 5 plus 5 equals 10. Is that true or false?
True.
True, which means that this is a real solution. Okay? So there is no, it's supposed to be NA. There are no extraneous solutions here. Make sense?
Yep.
So for number 2, we need to get that root by itself.
So you're going to add the 5?
Exactly. I'm going to square both sides. That gives me 4x plus 1.
Equals 25.
Good. 4x equals 24. If I subtract 1 on both sides, x equals 6, right?
Mm-hmm.
Now we need to verify it by plugging it back in. Four times 6 is
24.
24 plus 1.
25.
Square root of 25.
5.
5 minus 5.
3, 0.
So is it a real solution?
Yup.
Yes, because it produces,
0 equals 0.
exactly, it produces a true statement. And there are no extraneous solutions here. Any questions thus far? Okay. To move on. Number 3. So same thing here. We're going to add 5 to both sides. That's going to give me the square root of x plus 7 is equal to x plus 5. Good. And then once again, we're going to,
Square root.
not square root, but
Oh,
square.
square, sorry.
That's okay.
Square root.
Don't worry, like everybody has today. And then here's the thing that a lot of people mix up. They think you can just square the x and square the 5, but you can't.
Do like a binomial.
2 binomials, good. So you're right, you either have to do FOIL or box method here. I'm going to be using FOIL, but if your preferred method is box method, go ahead and do that. So this side is going to stay the same. First times first, outer times outer, inner times inner, last times last. These are like terms, right? Now I'm going to do something a little different. We don't have just one type of x that can be solved for here. So what we're going to have to do is actually factor this. Now in order to factor something, it has to be equal to what? 0. So I'm going to get this equal to 0 by bringing everything on the left over to the right. You see? Once you do that, you just combine like terms. And this is a quadratic, isn't it? So quadratics can factor into 2 binomials, right? Does anyone remember the procedure we used to do that?
The box method?
Well, we're actually doing the opposite now. So what are a factor or 2 factors of 18 that add up to 9? You remember this? 6 and 3. So when you have an x to the second power in your answer, you know you have to get everything to one side and then factor. Okay, that's the difference between a linear and a quadratic type of solution. Now, how can I find the answer to each of these? I can set each of them equal to
0.
which gives me x equals and good, but we're not done because what do we have to do with them?
Input them.
Yeah, I have to plug them back in to verify if they are solutions or not. So I'm going to start with the -3 first. So I just rewrite the original equation, but instead of x, I'm putting in a -3. Okay? What is -3 plus 7? Good. Square root of 4 is?
2.
What is 2 minus 5?
-3.
Good. So this one checks out. -3 is the solution, right? But I don't know if -6 is, so I'm going to leave this open-ended so I can possibly put the -6 in there. So I'm going to do the same thing. I'm going to take the original and I'm going to plug in the -6. What is -6 plus 7?
1.
Good. What's the square root of 1?
1.
Is 1 minus 5 equal to -6? No, that would be -4. So is that one a solution?
No.
No, so that one is classified as extraneous. And then you can close this one because we verified there are no additional solutions. Make sense? Okay. So whether you have to factor to get your answer or just simply isolate the x depends on what you end up with as a result. Okay? What's going to be our first step for number 4?
You're going to subtract 3.
Good. Then what?
Then you're going to square both of them.
Good, because what you do to one, you have to do to the other. I have to write this out twice. And then I'm going to have to FOIL this. Combine these like terms. And here's a scenario where I have another quadratic, right? So what's going to be my next step?
You're going to subtract the 5x minus 1, so
Mhm.
you can get it to the other side.
Good. Just keep in mind if I want to reverse subtraction, I'm actually going to do addition on that term. See how this one, you see what I'm saying? So these cancel, and this gives me 0 equals x squared minus 11x plus 10. And now we're looking for factors of 10 that add up to negative 11. Any ideas?
10. 10. Negative 10 and negative 1.
Good, negative 10 and negative 1. And then I need to set each of these equal to,
0.
which gives me x equals 1 and x equals 10, right? Now we have to verify these by plugging them back into the original. So I just rewrite the original equation, but instead of x, I'm putting in the number for x that we just solved for, which is 1. So what is 5 times 1? 5 minus 1?
4.
Square root of 4?
2.
Is 2 plus 3 equal to 1? So is this one a solution? No, it's extraneous. Now we don't know if 10 is going to be real or extraneous, so we have to plug it in. So I rewrite my original equation, but instead of x, I'm putting in the 10. What is 5 times 10?
50.
50 minus 1?
49.
It's the square root of 49.
7.
Is 7 plus 3 equal to 10?
Yes.
So this one is a solution. Now that I've checked them, I can close my brackets for both of them. Any questions on number 4? Anyone need more time? I'll take a second so you can catch up if you need to. So number 5 is a little bit tricky because what do you notice is different about number 5?
There's 2 radicals.
2 radicals. So if you see the instructions on your original notes page, it says that you want to isolate the more complicated of the 2 radicals. Which one of these radicals would you determine to be more complicated?
X minus 12.
Good. So to do that, I'm just going to add this one over. Now I can square both sides. So remember, if you have a binomial squared, you have to write it out twice and use FOIL.
Why are the radicals so rare?
Because we squared this one in the radical when it makes the whole thing's in a radical. This one we're squaring a mixed expression that has a radical and a number in it. So when we square it, we're going to have to use FOIL. So what's 2 times 2? Good. First outer. So that's just going to be plus 2 radical x, because you can't multiply inside a radical unless you're another radical. And then last, we have the square root of x times the square root of x, which is
2 square root of 4 square root of.
we have this times this. This is the square root of x squared, which is
X.
x. So anytime you multiply 2 identical square roots, it's whatever's inside the root, okay? Now we can combine these like terms. Okay. Now this is not one of those factoring scenarios because we don't have x squared. But what I do notice is I can subtract x on both sides, and what's going to happen? Don't they both cancel out? Everyone see that? How they cancel out? So this leaves me with negative 12 equals 4 plus 4 radical x. Oops, sorry. now I can subtract 4 on both sides, right? That gives me negative 16 is equal to 4 radical x, and then I can divide by 4 on both sides, which gives me negative 4 is equal to radical x. So that's as far as I've gotten so far, okay? But here's the problem. Now, you could go ahead and solve this, if you wanted to, by squaring both sides of this, right? Which would give me x equals 16. Would you agree with that?
Yeah.
So here's the problem. Now, this is our possible solution, but I can tell right off the bat that this is extraneous. Because if I look right here, at this sentence right here, let's think about this for a second. X represents some number that we're taking the square root of, that gives me a result of negative 4. Is there any number that you can take the square root of that gives you negative 4?
No.
So off the bat, I already know this is going to be extraneous. Now, if you don't want to, try to do that intermediate step, you could have went through all the same procedures that we just went over like before and plug it back in, and you would have verified that it is extraneous. So I want to let you know that the same procedure will work if you want to use it, but this is a shortcut. On some cases that will happen. So does anyone have any questions about that? Okay. We have one more problem to try together, and then I will go over question 4 on your homework. So this question is actually one of the easiest types. When you have 2 square root terms on each side, you can simply just square both sides, which gets rid of the square root on each side. And now you're just back to algebra 1. So subtract x. I'm lagging a little. So x equals 9, right? Now I need to verify it, so I take it and I plug it back into the original. What is 2 times 9? 18 minus 7? Is square root of 11 equal to the square root of 11?
Yes.
Yes. So when you get a square root of something equals the square root of something, you don't have to proceed and get the square root decimal, because you can see square root of 11 is equal to square root of 11. So take it a second to get that down, and then I'm going to go over number 4 on the homework. Just because I got a lot of questions about it, and it's probably good I address it. So if you have your homework open right now, before we even get into it, number 6, for example, I'm not going to go over it, but you see how number 6 is a cube root instead of a square root?
Yeah.
You're going to add the cube root of x over and then put everything to the 3rd power instead of the squared power to get rid of those roots, okay? Make sense? Okay. So let's go ahead and talk about number 4. So number 4 for you guys is the square root of x minus 3 is equal to the square root of x plus 4 minus 1. So this question is a little tricky because you can't completely isolate either one of these square roots, right? Because that 1 is in the way. So what we have to do is we have to just work with it the way it is. We're going to square both sides. This is going to cancel, and that leaves me with x minus 3 is equal to. I'm going to have to write this out twice to FOIL it. But it's weird to FOIL because we have an x plus 4 inside the root. So when I go to FOIL this, when I multiply the square root of x plus 4 times the square root of x plus 4, it's just going to become x plus 4. Because the square root times another identical square root is equal to what's inside the root. Then the outers are going to be negative root x plus 4. Negative root x plus 4. And then last, we have x plus, or just plus 1, because negative 1 times negative 1. So everyone see how we got there. Now, this right here has those implied 1s in the front. So this is just this. These are like terms, so I combine their coefficients. Now here, these are also like terms, right? And what you're going to notice is we want to get this by itself right here, the root. So I'm going to subtract x on both sides, and I'm going to subtract the 5 over. That leaves me with, what's going to happen with these x's right here? Cancel, which leaves me with negative 8 equals negative 2 times the square root of x plus 4. What can I do to get the x plus 4 by itself now? Not yet, because we got to get rid of this. So what can we do to get rid of this? Divide. That gives me 4 equals the square root of x plus 4. Now we can square both sides, right? 16 equals x plus 4. Now you can finish it off from there, right? So x equals what?
12.
Yes. And I don't know if it's extraneous or not. You're going to have to check that. But does that help get you started on that one? So homework 1 through 12 due tomorrow night, and then tomorrow we'll work on Delta Math in class.